Some people believe black holes to be entirely make-believe, while others consider them to be the most real things in the universe. For most of us, however, black holes don't seem to be something that's completely unbelievable, but it also doesn't seem to hold any substantial importance. My goal today is not to convince you that they are real, or even that they're relevant. Rather, I hope to provide a simple yet well-rounded explanation and description of these mysterious celestial objects, with the intention of creating awareness of the information that is currently available to us about them, and in doing so, to allow you to decide for yourself whether they exist and if they are indeed important. When thinking about black holes, the people who typically come to mind are individuals like Albert Einstein and also Stephen Hawking. However, while it is almost never talked about, the concept of black holes was actually first introduced a few hundred years prior to either of these people being born. According to the Cosmic Horizons curriculum collection created by the American Museum of Natural History, the conception of the first idea of a black hole existing came about in the year 1783 by a man named John Michell, an Englishman and professor at Cambridge University. Michell taught multiple subjects, including Hebrew, Greek, math, and geology. Outside of teaching, John was very active in the science community. One of his most notable research topics was that of stars, and in particular, the mass of stars, and how we, with our current technology at the time, could potentially be able to calculate exactly how much mass is in a star. The theory that he introduced in order to come up with a solution for this problem revolves around the speed of light and its relationship to gravity. It is generally understood that gravity is directly related to mass, and it is also generally understood that light, in order for us to view it, must travel from an object into our eyes. Now, that's kind of where his general theory revolves. If light can escape the gravity of a star, then we know that the speed of light is greater than that gravity. And that speed at which light can escape the gravity of a star is referred to as the escape velocity. Now, in the end, John Michell's theory of this concept essentially was proved to be incorrect, an incorrect way of calculating the mass of a star. What's an important takeaway, though, is that an escape velocity does exist. That is, there is a point at which gravity can overcome the speed of light and not allow it to escape from an object. And at this point, that object with such a massive amount of gravity would be referred to as a black hole. Now that gives a very complicated and difficult to understand description of what exactly a black hole is. So, in simple terms, a black hole is just a region of space that nothing can escape from. This is due to the large amount of mass that is compacted into such a small region of space, creating an extremely large amount of gravitational pull. There are different types of black holes according to NASA. There are stellar black holes, miniature black holes, and the type that is most commonly thought about, supermassive black holes, which are understood to exist at the center of most, if not all, galaxies, including our own. Now, the question arises, if black holes exist, how do they come to be? Well, NASA also introduces a couple different theories as to how this happens. The first is when a star collapses. When you have a star with 100 times the mass of our sun, and it collapses or implodes in on itself, that mass becomes so dense in one area that the gravitational pull in that area seems to increase. And in doing so, it overcomes the escape velocity of light and really anything else that could possibly travel near it, thus becoming in itself a black hole. In addition to stars collapsing, two existing black holes could collide, and is understood to be a common way in which supermassive black holes come into existence. Now, outside of a star collapsing and black holes colliding, two stars can also collide, and by this, the mass of both stars draw into each other due to the large amount of gravity that is existing in that area, and as a result, brings about yet another black hole. Prior to 2019, black holes were very hard to detect and seem to be still a theory. Things like X-rays could be translated and possibly understood to be effects of a black hole within our universe. However, until 2019, we actually did not have any images of a black hole or its effects in our universe. We only kind of guessed that they still existed. In April of 2019, however, the first image of a black hole was taken by NASA, and you can actually see through a Google search pretty quickly that there is a circle in space in which red light radiates off of it, which is translated into visible light from X-rays and gamma rays let off by the black hole. Now, we have a large amount of evidence that black holes do exist. But what is the importance? Well, according to The Economist, black holes and their existence would solve numerous physics problems that scientists have been stumped with for years and decades. Things like string theory or wormholes, or even fundamental things like gravity, would make so much more sense if black holes could be studied closely and we could increase our knowledge based off of research in this field. And through this greater understanding of physics, things like space travel and even physics on our own planet would be more easily understood. So with this information, I leave it up to you. Are black holes existing with the current evidence we have available? And if they're not, or if they are, is it even important? Thank you.